Hi guys, let's see today's Leetcode problem of the day. Earliest finish time for land and water rides one. So here we are given two categories of theme park attractions. One is land rides and water rides. That is, in a theme park, there are two types of rides available, land rides and water rides. Now for each of the rides, we have given the array which contains the earliest time the ride can be boarded. So, like for land rides, land start time of I contains the earliest time at which the ith land ride can be boarded, and land duration of I contains values how long ith land ride lasts. Similarly, for water rides also there is start time and duration. Now, there is a tourist. It want to experience only one ride from each category. That is, he or she will take one land ride and one water ride, and they can take in any order does not matter, and a ride may be started at its opening time or any later moment. That means if for ith ride the time is at t, so we can start that ride at from minimum time t, and if we can wait also, we can start at t plus 1, t plus 2, t plus 3, and so on. But at t minus 1 we cannot start that ride. And if a ride is started at time t, it finishes at time t plus duration. So like if ith ride starts at start time I, then it will end at time I plus duration of I. And immediately after finishing one ride, the tourist may board the other or wait until it opens. Like if the ride completes at time t and other ride is available at the same time t, the tourist can board. But next ride is not available at t. Suppose it is available at t plus 2, then the tourist has to wait for 2 unit of time to take that ride. So we have to like return the earliest possible time at which the tourist can finish both the rides. So we'll take example to understand this in a better way. So here, like we are given the two land rides are there and one water ride is available. For that land ride, the start time is this and duration is this, and for water time, start time is this. Now the tourist have many options. He can take 0th land ride, then water ride, or first land ride, then water ride, or water ride, 0th water ride, then 0th land ride, 0th water ride, first land ride, and so on. Many options are there, but from all those options, in which option or plan he will be able to finish at the earliest time, that we have to return. Like if he follows this plan A, where he'll take first land ride 0, then water ride 0. In this way, he'll start at 2, then 4 units of time he will take. So first ride he will be able to complete at 6. Now second, he wants water ride, it is available at 6, so he'll immediately take that, and it will take 3 units of time. To at 9 he will be able to complete both his rides. If he takes plan B, first he'll do water ride, then he'll do land ride 1. So water ride here is 6, and if it will take 3 units of time, so water ride he will be able to complete by 9. Now if he'll take land ride 1, which will start at 8, but he was doing water ride only, so he can only start at 9. So he'll start at 9 and 1 unit it will take, so he will be able to complete this in 10 units, earliest at time 10. Similarly, if we'll see other options, in that also it will take 12 units of time, 13 units of time. So 9 is the earliest time at which he will be able to do or complete his both of his rides. So we'll return 9 as the answer. Now, if we see the constraints of this question, this is like till 100. So brute force approach also will work for this. So let's go to brute force approach. Brute force approach is simple. We'll find end time for all possible combinations, and then we'll return the minimum end time. This all possible combinations we can simply find by using nested for loop. Like for land ride, there are n1 in the elements present in land ride. So it will go from 0 to n1 minus 1. Then j will go from 0 to n2 minus 1 if n2 water rides are there. for all the combination we'll find what is the minimum end time we are getting, and we'll return the we'll find the end time for all the combinations, and minimum end time will be our answer. But one thing we have to remember, that for every combination we will have two options. We can either take land activity first then water activity, or water activity first then land activity. Let's see the code to understand it in a better way. So the code is straightforward. Here we are trying to explore all the possible combinations. So N1 land N1 options are there for land rights, and N2 options are there for water rights. To explore all the possible combinations, we are using nested for loop, where I is going from 0 to n1 minus 1 and j will go from 0 to n2 minus 1. Now for every option, every combination, we have two options. We can do first land activity, then water activity, or first do water activity and then land activity. So suppose if we are doing first land activity, then we'll take for that combination at what time we will be able to complete that land activity. That will be start time plus duration. Now we'll find next activity at which time we can start, because it might be possible that our land activity is completed but next slot is not available for water activity. We might have to wait. So we'll take maximum of land activity finish time plus water start time for that j for that combination, and after that we'll update that answer if that result we are getting from here, or the end time we are getting from this combination, if it is less than our answer which we are storing, we'll update that answer. So the at this activity the time will at end time will be next start time plus water activity duration for that specific combination. Second option is do water activity first then land activity. So first we'll do water activity, it will finish at water start time plus water duration. Now same possibility is there that water activity might have finished, but for that combination the land activity might begin late, so we have to wait. So we'll for next start time we'll take maximum of both. After that, for this activity, that end time will be next start plus land duration, because we are doing land later. And if it is less than the answer, then we'll update the answer. So after running this loop for all the iterations, this answer will contain the minimum end time. We'll return it. Now this is earliest finish time for land and water rights too. This is exactly same question, only the constraints are bit higher. Here the constraints are till they can go till 5 into 10 to the power 4. So as we have already seen that for every combination we had two options. Either we can take land activity first and then water activity, or water activity then land activity. So if we think in a greedy way, because let's see, first we are taking land activity then water activity. So that what tourist will do, it wants to complete the land activity in minimum time. So it will explore all the options in the in the like land activity, and whichever will complete at earliest it will choose that. Now we have the finish time for the first activity. Now we can explore the all the elements of the second activity, and whichever is taking minimum time we can take that. But only one thing is we need to remember that for second activity the start time will be maximum of finish time comma start time of that element which are we are exploring, and after that duration we can get from there only. So we'll see the code to understand it in same approach in a better way. So this is a generic function which we have taken here. Start one represents the activity which we'll do start first. Like if we want to do explore land first then water, so start one will contain the starting time of the land activity. If we'll do water activity first, then start one will contain the starting time of the water activity, and this start 2 contains the starting time of the activity that we'll do second. So for the first activity we'll explore all the activities and we'll choose that activity for which the finish time is minimum. So simply we are traversing in the start time array of that activity, and we are finding the end time for that. And we are, if the end time is less than the end time which we have stored earlier, we are updating this finish one. So this finish one contains the minimum end time which we will need, or which we will able to do this first activity. Then after that first activity is done, we are trying to do second activity. So simply we'll explore all the elements and we'll find the time, and if that time is less than the finish time of second activity, we'll update the finish time of the second activity. But only one important thing to note here is we can start that second activity only if, like, only if it is like after the finish time, and if it is starting before the finish time of the first activity, then we have to wait until finish time of one. So simply this same thing we are doing here, start equal to max of finish one comma start two, and after that we are getting finish two. So now this is simple only. The tourist has two options. First option is, first do land ride activities, then water activities. It will take time t1. Second option is, take water activity first, then take land activity. This will take time t2. We'll return the minimum of t1 comma t2. See, earlier approach, our time complexity was big of n cross m because we were taking every combination. Here, since we are not using nested loops, our time complexity has dropped to big of m plus n or n1 plus n2, whatever you say, from like n1 cross n2 to n1 plus n2, it has reduced. Thank you.